Today we're going to start talking about inverse trig functions. So if you remember, like logs and exponents are inverses of each other. We switch the x's and y's, the inputs and the outputs. And so with trig functions, the output values of a trig function will be the angle measurement. Because before we inserted an angle and we got a value, so now we'll get a value and insert the angle. Now a couple things. You probably saw these last year is with the inverse symbol. It's also called the arc sign. So you can read those the same. So if I asked you to write the statement of pi over 6 equals 1/2 in equivalent form using the arc sign notation, what all we would do is write the arc sign of half equals pi over 6, or we could write it the inverse sign of pi over 6, or excuse me, the inverse sign of 1/2 gives you pi over 6. So as we can see, we're inserting our input is that side length, the value, and our output is the angle. So let's take a look at the graphs of these. So if here's the sign of x, what does the inverse sign look like? So again, we switch our x and y's. So you'll notice the scale got switched, right? We have 1, 2, 3, 4 on our x-axis and our angle measurements on our y. So 0, 0 stays the same. What is this coordinate? Is pi over 2 and 1. So it becomes 1 and pi over 2. Then we had the coordinate pi and 1. Pi and 0, excuse me, so it comes 0 and pi. Then we had 3 pi over 2 and -1, so it becomes -1 and 3 pi over 2. And we can kind of see here, that is let me try drawing that again. I might put in a few more. So here is our arc sign. And so we can do the same thing with the cosines. We switch our x and y. So this is the coordinate 0, 1. So it becomes 1, 0. Pi over 2 and 0. So it becomes 0 and pi over 2. Pi and -1. So -1 and pi. 3 pi over 2 and 0. So 0 and 3 pi over 2. And then 2 pi and 1, so 1 and 2 pi. So we can see here, again similar, but it would be at 1, 0. And then our arc tangent. So again, this one, we had asymptotes at pi over 2, so now they're going to become horizontal asymptotes. And then again, 0, 0 would be the same. And then as it goes towards pi over 2, it kind of goes higher and higher. So as it gets higher and higher, it goes to pi over 2. So it's like it's turned on its side there. All right, so now when we're talking about inverse trig functions, we have to what's called restrict their domains, because otherwise remember the vertical line test? This is not a function, right? Because it hits it twice. So what we do is we restrict their domains when talking about inverse functions. This makes it so we don't have to say everything, like for an inverse, we restrict the domain. And our domain restriction for sine is right here, because then its inverse is a function. So if we went back up here, so that's from -1 to 1. So all we're talking about right here is from here to here. Cosine, we restrict just from 0 to pi over 2. And tangent is restricted between -pi over 2 and pi over 2. So when we're working with these restrictions, again, here is our restrictions, right? Because then we don't have the values repeating. You can see we have positive sine values and negative, positive cosines and negative, and the same thing for tangent. So when you see something like this, it says evaluate the following expressions. The inverse cosine of root 2 over 2. So cosine is restricted to the top two coordinates, right? Because we want to know where our cosine is negative root 2 over 2. And this is where it's in the top and the bottom coordinates. It's in quadrants 2 and 3 where our x value is negative root 2 over 2, but we only care about this quadrant. So what is our angle? It's pi over 4. So in this quadrant, it's actually 3 pi over 4. So what about this next one? We want to know what our sine is. And sine is our y value. So it's here. And over here, our y value is negative. But again, we only care about this quadrant. So opposite that is pi over 3. So in this actual quadrant, and you will notice it says between negative pi over 2 and pi over 2. So we can just say that this is negative pi over 3. Some of you might recognize that this is actually 5 pi over 3. But our domain restriction, it just says between negative pi over 2 and pi over 2. And then our tangent. I think tangent is a little tricky. So tangent, would it be this? Or would it be this? That gives us root 3. Well, it's going to be this. So that means on our triangle, and again, tangent is 1 and 4. So this quadrant would be root 3 over 2 and half. So that gives us the root 3 over 2. So this is pi over 3. So it would be pi over 3. All right, in example 3, and the angle is in standard position and the terminal ray intersects the unit circle at point P where the coordinates are x and y. The points Q, R, and S are the result of the terminal ray being reflected over the y-axis and origin and x-axis. So we started here and we reflected it. So this would be negative x and y. This would be negative x, negative y. And this would be x and negative y. For each of the following expressions, determine which labeled point intersects the terminal ray at the given angle. So the cosine of x. Well, our cosine of x, right? That's just angle P, right? Because our x is positive. The inverse sine of negative y, right? And because cosine is in the top two quadrants. Sine is in 1 and 4. So which one would be negative y? Well, that would be S. Cosine of negative x. Okay, well, let's see cosine. So that's the inverse cosine. So that's in quadrant 1 or 2. So that would be Q. And the inverse of y over x. Well, tangent, I look back up here, is in 1 or 4. So that would have to be S. All right, and the last thing we're going to look at, find the inverse of the function and graph it. So to find inverse, we switch our x and y. So 2 sine of y plus 1. So minus 1, x minus 1 equals 2 sine of y. Divide by 2. And then again, to get rid of it, we will, to get rid of the sine, we'll do the inverse. So I'm going to do the inverse of this and the inverse. So this side is just y. So we have the inverse sine of x minus 1 divided by 2. Now, how do you want to graph this? And there's a couple ways to do it. You could graph our original. So if I was to graph this, let's see, our period is 2 pi divided by 2, which is pi. So 1, 2, 3, 4. So if this is pi, then this is pi over 2. So this would be pi over 4. Our midline is at 1, and it goes up 2 and down 2. Sine starts in our center, and it would go boom, 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 boom. So it would go, whoops, that's not right. High, mid, low, mid. So this would be low, mid, high, mid. Okay, and it wants us for between negative pi over 2 and pi over 2. Okay, so here to here. Okay, so again, if we were to switch this, 0, 1 would become 1, 0. Pi over 4 and 3 would become 3 and pi over 4, which would be right here. And then pi over 2 and 1 become 1 and pi over 2. And then going backwards, negative pi over 4 would go down to negative 1. And then pi over 2 comes back to the center of 1. So it would look like that.